Okay, let's go on here, and I'm about to talk about establishing standard scores, which has to be done. That is a baseline data against which the particular client who that instrument is going to be used for, the performance of that particular client has to be compared to the typical population, right? An equivalent population, because norm reference scoring has something to do with comparing your particular client that you yourself as a clinician are assessing with what's typical of that particular population in the area, of course, of speech or language. Because we're using assessment instruments to make a decision, is the client's behavior typical within the parameters that are considered typical for the age or grade level, or is there a disability or disorder? Well, that means that the person who created that assessment has to somehow establish some kind of basis for making that comparison, because norm referenced assessment allows us as clinicians to compare our client with the population with an equivalent population, and with the norms of that equivalent population. So for each grade or age or grade level that the assessment instrument is designed for, the author has to generate a normal curve. That's how it's done. That's how the author establishes a baseline for establishing a standard score. Now, the term standard score means a scoring system. A standard scoring system means a scoring system against which a particular clients for whom the assessment instrument is used, for establishing a basis for comparing any individual with the norms of a particular equivalent population. Well, to do so, to allow the instrument to be used this way, the test author has to create the following statistics: a mean for the equivalent population, a standard deviation for the equivalent population, a Stanine for the equivalent population, a confidence interval for the equivalent population, a percentile rank for the equivalent population, a standard z-score distribution. And how does the individual do that? And what do these terms mean? Mean, standard deviation, Stanine, confidence interval, percentile ranks, z-score distribution. What does this mean? What do these terms mean? And how is it done? Well, as you see in my little blurb comment there, for each age or grade level that the instrument is designed for, the author must generate a normal curve, because the normal curve, bell curve in other words, is the basis for derivation of a mean, standard deviation, Stanine, confidence interval, percentile rank, and a standard z-score distribution. Actually, all of these terms are interactive and related to this idea of a distribution. Well, what is that normal curve? It's also called the bell curve. What is exactly that thing? Well, it's one of these things here, isn't it? Everybody here is familiar, I'm assuming, with this figure. What does it stand for? What does this stand for? Well, this stands for the central tendency and range of performance of a particular population on a particular assessment instrument. Again, this is the central tendency, that's the hump in this curve, central tendency, and range of performance, that's this whole part. Notice that the curve has a very high point and then goes out to the edges, it kind of drops off. So this high point here refers to this high area here, the tall area here, that refers to the central, that really is a picture of the central tendency of any particular population. And these side parts, that is these really represent the range of performance. In fact, the whole the variation within the curve represents the range of performance of a particular population on a particular assessment instrument. One of these would be so the particular population are each age or grade level that a particular assessment instrument is intended for. Each age or grade level requires that the test author generated one of these curves so that we clinicians out here, when we choose an assessment instrument, the assessment instrument to administer, can get a raw score from our client and compare our client's score with this central tendency and range of performance that the equivalent population, the equivalent group of individuals out there in the world demonstrated. Are you following me? So some of the statistics are applied to this to generate a mean, standard deviation, those types of scores that standard scores that are used to compare our clients to. Now, how do you get a curve like this? Well, if you test, it's just the way, there really is there's an answer and then there's no answer to that particular question. But if you assess, if you say you were evaluating foot size to create a, say you want to have you decide to go into business and create a group of a brand of shoe store, and you want to know how to stock that store. Well, you might go out there and measure the feet of the population for whom shoes in your store are intended, right? You decide to go into the shoe store business, right? Well, you can commission a study, and for each age level that you are having shoes for, you want to stock your store for, you could measure the feet of say you're doing an adult woman's shoe store. Well, you can go out and measure adult women feet. You can sample the population out there for whom you are designing shoes. And you would actually go out there with a tape measure perhaps, or something like that, and measure feet. Well, not everybody has the same size feet, right? So you would get a range of feet sizes. You can then apply statistics to that range, statistical analysis procedures, and you would end up with a curve just like this. Why? Because of the way any population operates is. And that is, you will get a central tendency, you'll get an average shoe size if you add up every single score and divide it by the number of individuals you sampled, right? You would get an average. Another word for average is mean. But there'd be differences among individuals, wouldn't there be? Not everybody would have exactly this, you wouldn't have a bunch of exactly the same foot sizes, not unless you have a population of clones. So you would have an average, and then you could calculate an average difference from the average, right? Average difference from the average. Think back to your statistics course. That would be what the average difference from the average refers to. What kind of statistic? Good. It is the standard deviation, the average difference from the average. And in fact, each line on this curve represents a standard deviation. You would get once you have calculated the average difference from the average, strangely enough, if you added that average difference to the mean score for the entire population, once, you would get one standard deviation, and you take the differences that are above the average. Well, you would get 1, 2, 3 standard deviations and more above the mean. If you subtracted that average difference from the average score, well, you'd get 1, 2, 3 standard deviations down. For those, if you're only using those differences that are below the average. I don't have time in this class to actually calculate and run this, play this out for you specifically, but think about this and how it compares to the information that you hopefully acquired in your statistics course or some other, or your research course too, correct? Think about it. So in any event, you do what the author of the assessment instrument does is establish for their baseline population upon whom the test was normed, a mean for each population. Say the assessment instrument is designed for school-age children. So they go, and it's designed for first graders through high school students. Well, the author has to generate a curve for first graders, second graders, third graders, fourth graders, fifth graders, right up through 12th graders, right? Because kids grow. Feet size get bigger. Language behavior shifts from year to year, correct? So you need a curve for each year, and for each population for whom you claim that the assessment instrument applies. I'm going to come back to that point in a moment. But if you took the raw data, and calculated a mean and range standard deviation score, say, the average difference from the average above and below the mean, that would establish a baseline against which any client who is from the population that the curve was generated for could be compared to. And you would therefore be able to determine whether the individual client is within the average range, or below average range, or above average range. Yes, if one of these things was generated. And notice, by the way, so let's just review some of these. Let's go back for a second. Norm reference scoring, therefore, again, to remind you, is scoring with reference to how raw scores of the particular client compares to the central tendency and range of performance of an age or grade equivalent matched population. Raw score means the actual criterion referenced, the actual numbers, the actual average and range, the actual score that an individual has achieved on a particular assessment instrument. And to back up one tape more, yes, to back up a little more, we are going to, the scores that are going to be yielded again, that appear on these curves, that come out of these curves and are going to be used to score a particular client. You include a raw score, and the raw score is calculated by actually giving 1 point to, typically on a standard norm reference assessment, 1, 2, or 3 points are assigned to each correct answer, and 0 points are assigned to each incorrect answer. And there are correct and incorrect answers to questions or behaviors that are evaluated as correct or incorrect. And they actually get points. So they're scored just like your midterm would be scored, say, in this class or your final, by a decision as to what is a correct answer, what is an incorrect answer, and points would be assigned. That's criterion reference scoring, by the way, not norm reference. That's the first step of norm reference scoring, but the first step is to calculate a criterion reference score. Criterion reference means performance against a criteria for getting points or not getting points, for correctness or acceptability or non-acceptability. I'm no fan of the term correct or incorrect, but that does apply to these standard norm referenced assessments, because points are given for responses that are considered acceptable by the test creator, and points are taken away for responses that are considered not acceptable. So a raw score is calculated, but that raw score has to be transformed, changed into some kind of a score that gives the test user, or the person who reads the diagnostic report, some kind of information about whether or not their client performed within the average range, above average, or below average, to see if that person qualifies for service or not, requires service or not. Thus, a standard score is derived. And that standard score will be a score that represents a comparison. It is a comparison score, a score that allows you that embodies a comparison between your client and the mean and range of scores established from a baseline population. Now, there's another kind of score you can derive, and that is called a confidence interval. And there's an error on this slide I see. It says this. It's like an icon, a little smile, left-hand smiley, sideways smiley face, but parenthesis really. At 0, it's not. It should read at 90 or 95% confidence. What is a confidence interval? Well, you can make a decision, and when you report a score, whether you want to simply report the actual raw score the person achieved, but that's not going to get you too far. You can report a single standard score, a single comparison between that client and the baseline population, to indicate exactly how that client performed at the mean, below the mean, above the mean. Where? One score. Or you can say, well, listen, I gave a test. The test had a number of items on it. I gave that test at 10 o'clock this morning. I'm not exactly sure how the client was exactly feeling this particular day, whether the client was really attentive to every single question, etc. I'm not sure if I give the test, had I given the test, say, in the afternoon, on another day maybe, or in maybe the room that particular day had a light out or a distraction or something. I'm not sure if that particular number that the client achieved that particular day would be the same exact number on the next day or the following day. Maybe the test question had something a little confusing in it that the client would figure out on another time. Maybe it would be fair that for me to, rather than report one single score that represents performance, I should, it would be maybe fairer to report a band or range of score, a confidence band or a range of scores that would reflect how that client would perform on any day, at any time on that instrument. What is a range of performance? Think about standard norm reference assessments you've taken in your life. I don't know if you took the SATs or GREs, but there are many, many questions on these tests. And you know how it is. Maybe you guess at a couple. So on a good day, you guess correctly. On a bad day, you miss a guess. Say you took the Ashapraxis exam and you failed by 1 point. 1 point. You would want to shoot yourself, right? But if there was a way that the ETS people scored that praxis so that they would report a score they would have a way of deriving a score that would represent your performance on any particular, across at any time, as a range, which would really, you realize that on some days you might do a little better than on other days, right? It's also, this idea is also related to the reliability of that test, the range of performance that is associated with that particular assessment instrument. The consistency, rather, the consistency. Well, there are each of these assessments in the scoring manual has something called, see right here, you can't probably see it, but it says confidence interval. And these tests actually allow you not to simply report one single standard score, in terms of a client's performance in terms of a single standard score, but how you can make a statement. I want to be 90 or 95% confident that any time I gave that test to this client, this is the score I would get. Well, you would then you have the option of reporting a range of scores within which you can be confident that the client will perform. That's called a confidence band or confidence interval. And that's another norm reference score that can be reported. Percentile ranks are another norm reference score that can be reported and that come from these curves, and that is scores can be sequenced from high to low, and you can report scores in terms of what proportion of clients individuals who take this assessment scored more poorly than the particular client. So if you find that the client performs at the 97th percentile, that indicates that 97% of everybody taking this test scored more poorly than this particular client. That's cool. That's a good, nice place to be, because only 3%, if you subtract from 100, you would find only 3% of the clients performed higher. Well, that means that's strong performance. On the other hand, maybe the client performed at the 10th percentile. Well, that means 10% of everybody who took that test scored poorly, but 90% performed better. So percentile rank is another kind of comparison score. And there are also a Stanine score that I'll come back to a little later in a moment. And age equivalent score, you can derive a score that indicates at what age, based on the client's raw score, at what age is that raw score a mean? Represent the mean for a particular population. So the client may perform more poorly than the client age equivalent individuals on a corresponding age population, but that raw score could represent the mean, say, rather than for, say, 6th graders, the mean for 4th graders. So you'd say, well, that person has an age equivalent score or a grade equivalent score of 4th grader. Or what's a 4th grade age? Like 9 years or something like that? 8 or 9 years of age. By the way, you can never report an age equivalent score alone. You can report a standard score, but not an age equivalent score. Why? Because it's not quite kosher to compare a raw score of a particular client with the average from a different curve generated on a different population. Remember, the curves are generated on an equivalent population, age and grade equivalent. And it would not be kosher it's really not statistically kosher, appropriate to be comparing scores coming from one population to scores that were derived from a different population. It's done, but it's not really acceptable by itself. It's just kind of a note you make for comparison's sake. Well, let's go back to the curve again, if I can. I'm not going to go any further than this, other than to go back to the curve, if I could find the curve. No, what happened to my curve? Where is my curve? There it is. See my curve? Okay, again, so notice there's a mean. So you can now notice this, the numbers on the bottom here on the curve, that's not a raw score is something like, say there's 100 items and the individual gets 1 point for every item. Well, the average score of a group of, say, 3rd graders taking a test where there's 100 items, well, the average score might be 22. So what does this 100 refer to, if this is a curve for 3rd graders? Well, the raw score is transformed to a score that would indicate to anybody who looks at it whether the client is at the average level above or below. That's called typically a z-score. A statistical operation is performed on this raw score that yields a score that allows us to look at the score and immediately know whether our client is average, below, or above in terms of performance in comparison to a base population, an equivalent population. So say the 3rd grader gets a 23, and the 23 was the average of all 3rd graders taking that's the raw criterion referenced average. Well, that's transformed to the number on 100, so that when I read a diagnostic report, I look at that number, I know that client was average. And it's typically the case it's universally the case, in fact. On these standard norm referenced assessments for standard scores, that 16 points is the number assigned to a particular any standard deviation is 16 points. 16 points is given 16 points, or in this particular example, to make it easier, 15 points. So if you take away 16 points from 100, you get 84. In this case, they took 15 away and got 85. When I look at the score 84, I can immediately know, if I see that an individual has achieved an 84, I know that individual is one standard deviation below the mean. And it doesn't matter if it's on the Goldman-Fristow standards test or the self-5 standard test, standard norm referenced assessment, or the PLS 5 preschool language scale, or an IQ test in the cognitive domain. Doesn't matter. 100 is mean, 84 is one standard deviation down. I know if I add 16 and 16 up, get 32, and subtract it from 100, I'll get 68. I see a 68, I know that client is 2 standard deviations below the mean. If I get 52, I know the client is 3 standard deviations below the mean. If I get 116, I know the client's 1 standard deviation above the mean, because 16 points universally is assigned to a standard deviation. That's a standard number. So you should kind of like internalize those numbers, so when you look at a diagnostic report and you look at the language, the overall performance of the client in the receptive or expressive area, in articulation or whatever, and you give a standard score, you can look at that standard score and know, could know how that client, whether that client was at the mean, below the mean, or above the mean. And you need to know that because you're going to be qualifying your client for service based on these numbers. Following me? Now, if you had the raw score, you'd never know that. Like if you got a 23 on the, say, Goldman-Fristow, a 3rd grader on the Goldman-Fristow got a, sorry for the noise in the background here, you received your client received a raw score of 23. Well, 23 on the Goldman-Fristow would be different, you know, a 4th grader, you don't know, what the heck is that? Well, that's works for Goldman-Fristow, the latest edition, but later on in another edition, that number may be different. And if your client, it's just your client's, you know, criterion reference performance, but if that number could be changed to a number that's standard for all individuals taking the test. If that number can be compared to the mean, and the mean would be assigned 100, and that number, the raw score, the test will take care of the raw score, but you could report that could be converted to a standard. That's why the term standard, a standard number that represents performance with relation to the comparison population. Well, then you have a basis for making reporting in a way that is comprehensible to any reader of a diagnostic report, and a basis for assigning a client, making a decision as to whether a client is delayed or disordered, or average, or even above average. That's as far as I'm going to go right now. I know I've rambled on a lot on this particular component of this lecture, and we'll continue on next time we meet.